In the legal world, they call it the chain of evidence. The chain of evidence starts at the crime scene, and each step of processing the evidence is critical. They document every possession and disposition of that evidence. If the chain of evidence is broken, you can't get a conviction. The legal system throws out the case because they can no longer be certain that something isn't right. In the assembly and manufacturing world, when it comes to torque tools, we call it the torque chain of quality. This torque chain of quality starts at the weights and measures process and continues all the way through to the last click of a torque wrench when it's time for your product to leave your dock. Each step of the torque chain of quality has varying degrees of tolerance built into it. Everything impacts everything else. It's an entirely variable system. But the key point is, it's a system. You can't say you have true error proofing or a true quality process unless you know for certain that each step of the chain has held its integrity. If any portion of the torque chain of quality is broken, you can no longer be certain that your product is what you say it is. Let's start with the weights and measures that are used to calibrate torque testers. Those weights, the arms that are used for balance, and the processes used to create those weights and the balance arms are highly standardized, they're monitored, and they're closely controlled. Even temperature and humidity is controlled to create consistency and standardization. Every weight is certified and it has a serial number, and it's recertified on a regular basis. If all that isn't done properly, your torque tool calibration equipment can't possibly be accurate. If the first step in the process is inaccurate, nothing else will be accurate. If that isn't done properly, your torque calibration equipment will not be accurate. In the quest for quality, little things mean a lot. If a pilot is taking off from Sydney, Australia, and he's flying to New York City, and he's 1 degree off at the time of takeoff, and he doesn't correct, he lands in Kansas City. If the first step in a process isn't accurate, nothing else will be accurate. If your torque tool calibration equipment is inaccurate, how accurate can your torque tools be? What if the weights and measures were up to standards, but it was something else? What if your Cal Lab isn't ISO 17025 certified and is not an accredited A2LA reference lab? Maybe they made a mistake in their calibration process despite the fact that they had the right weights and measures. Mistakes do happen. Some are just more costly than others. At this point, how do you feel about your torque chain of quality? Are you fairly confident? Maybe your torque testing equipment is accurate to within its promised degree of accuracy. Maybe it isn't. But let's say it's good to go for now. So let's test some torque wrenches. What if the calibration tech doesn't exercise the wrenches or the tester before he begins testing? What if the tech makes one of the other 8 most common torque testing mistakes? Is your accuracy level increasing or decreasing? Let's say everything is up to spec right from the start of the chain through tool calibration. What if the wrench that was just calibrated is dropped on its head and knocked out of spec, and that wrench isn't due back for calibration for another 12 months? Now what? If your torque tools aren't accurate, how accurate can the tension be on your threaded fasteners? Oh, by the way, torque testing equipment and calibration equipment, think those units are treated delicately? We've seen torque testers and calibration units come back to us torqued so far over capacity that we spend a lot of time scratching our heads trying to figure out, how did they manage to do that? There are other places that your chain of quality can go wrong. What if the spec called for grade 10 threaded fasteners and the manufacturer sent you grade 8 fasteners? What if the engineering spec called out for a range of 115 foot-pounds to 155 foot-pounds, but the joint that you were tensioning needed more pressure than the minimum number? Or what if they didn't get the right torque value because any one of the links, starting from the weights and measures to where we are now, were not up to standard? Then what? Oh, did we forget about the workers? How much variability is there when someone brings their personal problems to work? Real quality is truly an interdependent system. Each aspect of quality depends on the other aspects to do their job and to deliver their part. The game of quality is all about controlling the aspects that you can control and then doing your best to minimize the impact of the things you can't control. You need to trust, but you have to verify. How certain are you that the chain has not been broken somewhere and you don't know it? What is the cost of errors, rework, warranty repairs, lost customers, being flamed on the engineering boards? How do you protect your quality, your costs, and your reputation? This video series is about the chain of quality. More importantly, it's about your chain of quality and how to control as many of the interdependent aspects as you can so you don't do this to your customers.